Assalamualaikum, ma'am.
Thing I asked you now. Still, if you don't come in the class, then what is the necessary of taking class? Okay, wait until 5 minutes if anyone come. Otherwise, I will start after 5 minutes. Okay. Can you hear me properly? Respond to your roll number. Roll number 26.
Yes, ma'am.
Roll number 27.
Yes, ma'am.
28. Roll number 28. 29.
Yes, ma'am.
30.
Present, ma'am.
31. 31. 32. 33. 34. 35. 36.
Yes, ma'am.
37. 38.
Yes, ma'am.
Yes, ma'am.
Who said yes, ma'am?
Ma'am, 38.
Then 37.
Yes, ma'am.
39. 39. 40.
Yes, ma'am.
41.
Yes, ma'am.
42. Roll number 42. 43.
Present, ma'am.
44. Roll number 44, 45. Roll number 45. Roll number 46.
Yes, ma'am.
47.
Present, ma'am.
48. 49.
Present, ma'am.
50. Roll number 50. So have you studied that item number 1, the solution, the component of the solutions, and there are some definition I asked you to memorize. Have you studied that?
Yes, ma'am.
Yes, ma'am.
Okay. I'll ask. One second. I'll just receive. Okay, Captain. Roll number 38.
Yes, ma'am.
What is molar solution?
Molar solution. Ma'am, it is a solution in which 1 gram molecular weight of solute is dissolved in 1 liter of solution.
What is homogeneous solution and what is heterogeneous solution?
Ma'am, homogeneous solution is the solution of 2 or more substances showing all through same composition. Is called homogeneous solution.
Roll number 40.
Yes, ma'am.
What is the standard solution? What is standard solution?
Ma'am, in a standard solution, relative strength and concentration of solute and solvent are known.
Okay. Then you tell me what is molar solution? Molar.
It is a solution in which 1 gram molecular weight of solute is dissolved in 1 kg of solvent.
Okay. Roll number 45. 45 is absent. Roll number 43.
Ma'am, yes, ma'am.
43. Okay. What is normal solution?
A normal solution is the solution in which the equivalent of solutes is dissolved in 1 liter of solution, ma'am. 1 gram equivalent weight is of solute is dissolved in 1 liter solution, ma'am.
Okay. Then I think you all have a clear idea about solution. Now let's go to the classification of solution. Okay, listen carefully. I want to show a
Okay, ma'am.
slide here. The classification is solution. That solution is classified firstly is qualitative and quantitative. Okay, in qualitative solution is 2 types: colloidal solution and crystalloid solution. In your item 2 is only about the colloidal solution and crystalloid solution. So we'll discuss it later. And further, the colloids are also classified into emulsion and suspension. Then in quantitative classification, it is standard solution and non-standard solution. But standard solution is the definition we told right now. that is normal solution, molar solution. Only definition is okay for you. You don't need to learn the details of this. Okay. And non-standard solution is saturated, unsaturated, and supersaturated. But there is another important classification of solution that is according to tonicity. That is very, very important for you. You need to understand the mechanism of that. Because when you will learn further biochemistry about the volume disorder, because see, 70% of our body is fluid. So you need to know about all the mechanism, how the equilibrium is maintaining, and is about the tonicity. And according to the tonicity, the solution is classified 3 types. That is isotonic solution, hypertonic solution, and hypotonic solution. Okay. So today we'll discuss about this classification according to the tonicity, because you need to learn it very clearly. Without this, you won't understand the volume disorders later, and you won't understand in medicine. It is very important to know this isotonic, hypertonic, and hypotonic solution, because when there will be patient of severe volume disorder patient, like some can come with burn, they have also need fluid replacement. So you need to know which fluids will give to the patient. So from this chapter, you will learn about the detail of the fluids. Okay. So let's start. About at first, let's start with colloids and crystalloids. Okay. Then I'll discuss the hypotonic, isotonic, and hypertonic solution. It's very small. Okay. So what is colloid? Can anybody tell what is colloid and what is crystalloid? Anyone?
Colloids are the particles that cannot pass through the semi-permeable membrane.
What is the size of it?
Whereas crystalloids are the substances that can pass through the semi-permeable membrane.
Oh,
And this is the difference between the two.
okay. There are so many different. This is the one of the different. So let's. Okay. What is colloidal solution? When the size of the particle is between 1 to 100 nanometers in a heterogeneous mixture. You need to always remember that we learned that solution is a homogeneous mixture, right? But in a colloid solution, colloids mixture are always the heterogeneous mixtures. And the example is milk. So why? In sometimes we think that milk is a homogeneous mixture, but not. Milk is not a homogeneous mixture. See, it's a heterogeneous mixture. Why? See, here there are two phases. One is dispersed phase. In a colloidal solution, there will be two phases. One is dispersed phase and another one is dispersed medium. See, the dispersed phase is the solute and medium is the solvent. So what is the smaller proportion in a milk? That is the liquid fats dissolved in the water. This water is the solvent in the milk and the liquid fats are the solute in the milk, and both are making the colloid. So fat completely doesn't dissolve in the water. So it makes a heterogeneous mixture. Okay. So colloids are two types. I told you one is emulsion and another one is suspension. Okay, the emulsion, another name is lipophilic colloid, and suspension is lyophobic colloid. Okay, so what is emulsion? The colloidal structure in which the particles of the dispersed phase have a strong affinity for the dispersion medium. That is called lipophilic colloid. Okay, and lyophobic, that doesn't have or have a very little affinity to the dispersion medium. Dispersion medium mainly is water. That is called suspension. Okay, or lyophobic colloid. They have mainly organic compounds, lyophilic colloids, that is starch, gelatin, cellulose. But lyophobic colloids are mainly inorganic substances, like they are sulfide, ferric hydroxide, sulfur, gold, etc. So viscosity is greater in lyophilic medium and viscosity is same as dispersion medium in lyophobic. And the surface tension is generally less in the dispersion medium and it is not visible even under the microscope. But the lyophobic substances are always visible under the microscope. Okay. See, the lyophobic, that is suspension, heterogeneous mixture compounds of large particles that is visible to the naked eye, that is called suspension. This is one type of colloid. Okay. The suspended mud particle. This is a suspension, mud and water. But water in salt or water with sugar, that is homogeneous mixture, that is not suspension. See, that is the solution, milk is colloid and mud in the water, that is called suspension. Clear? Do respond, otherwise how will I understand
Yes,
that?
ma'am. Yes, ma'am.
Oh, yes, ma'am. Yes.
Okay, solution, the salt in water, that is a homogeneous mixture, colloid, that is milk, heterogeneous mixture, and suspension that we can see in the naked eye, that is suspension. And if we that mud in the water, that is suspension. See, this is the Tyndall effect of a colloid substance, that light can particles in a colloid can scatter the light in this way. Okay, this is called Tyndall effect. So let's come to the properties of the colloid. So you know the definition now. The colloids are the substances which are 1 to 100 nanometer and which cannot be passed through a semi-permeable membrane. The examples are protein, polysaccharides, gums, gelatin, etc. So these examples are important for your MCQ, and the colloids can come as a short note. Short note. There are some questions come in the written exam called short note, but that short note means you will write shortly. That is not. You have to write detail and everything of that topic. That means short note. Okay. When there you see a question that write a short note about the colloid or write the short note of the topics there, you have to write everything. This, if the comes as a colloid as a short note, you have to write the definition, then example, then properties. Okay. Short note means you have to write everything of that topic. And in the MCQ, we have a 20 numbers MCQ and 80 numbers question answer in the written. In written, as an MCQ, it can come which substance is colloids. And these MCQs are like true, false. Okay, there will be 5 options, A, B, C, D, and E. You have to write which one is true and which one is false. Not one answer like your previous. Okay, there will be 5 options. You have. There will be 5 options in a MCQ, A, B, C, D, E. You have to write which one is true and which one is false. Like, right, you have given what is the example of colloid. A, protein, B, polysaccharide, and C, D, E, others. So A and B is true. C, D, E, if it is not the example of colloids, you have to write that it is false. D, E, false. Okay?
Okay, ma'am. Yes, ma'am.
Now come to the properties of colloids. That at first I told it, now that size. Size is 1 to 100 nanometer. Okay. Then shape, it may be variable in shape. Okay. Then color is also variable. some solution, colored solution like gold solution is red, silver solution is gray in color, sulfur solution is colorless. Then sometimes colloidal solution can dilute starch, like appear slightly cloudy or opacent to the eye, and it has two phases. I have showed you that dispersed phase and dispersion phase, and they have exert low osmotic pressure. Okay, can they? These are the physical properties: the size, shape, color, then visible under microscope, cannot pass through semi-permeable membrane. Solution can be converted into gel-like structure, like gelatin. Gelatin is a colloid. Okay, then foam or cream. Cream is also a colloid solution. Okay, these are the physical properties. Then another properties, they have three main properties, that is the Tyndall phenomenon. They can scatter the light. Then they have the Brownian movement, the continuous, haphazard, zigzag, irregular movement. Okay, and the rate of the motion depends on the size of the colloid molecules. Increase size of the colloid molecules, decrease movement. Okay, and vice versa. And they have colloid carry electric charge on their surface. Okay, these are the properties of colloids. Then crystalloid. Crystalloid, the opposite of colloid, same, but the size is greater, less than 1 nanometer, and they cannot pass through a semi-permeable membrane, right?
Yes, ma'am.
See, components of colloids is dispersed phase and dispersed medium. Dispersed phase is that solute and medium is the solvent. Okay. The milk, mayonnaise, butter, they are the liquid form. Okay. Then properties of the crystalloid. So from what will be the then physical property? Size. Size will be less than 1 nanometer. They can pass through the semi-permeable membrane. Then their physical form, they are crystalline in nature. Then they are osmotically more active and they exert more osmotic pressure. They doesn't have any Tyndall phenomenon. Then they doesn't have any Brownian movement like colloid, just normal regular movement, molecular movement.
We couldn't see the slide, ma'am. You're not sharing that.
Can you see it now?
Ma'am, it's
Yes, ma'am.
milk, butter.
No new slide. I haven't shown any new slide. I am just speaking. Okay. The
Okay.
characteristics of the colloids and crystalloids, I don't have any slide for that. Because it's easy now. And crystalloids are dialyzable, but the colloids are non-dialyzable. Okay. And crystalloids always form a homogeneous solution or true solution, but crystalloid doesn't. A colloid form heterogeneous solution. Okay, these the properties is that not very important, because you need to remember for your written exam. Okay. So you need to learn the difference between colloids and crystalloids for written exam, and difference between lyophilic and lyophobic colloid. That means difference between emulsion and suspension for written exam. So item 2 is only
ম্যাম
this.
আইটেম ম্যাম কোনো কোয়েশ্চেন দেয়া হয়নি, আইটেম 1 এর জন্য যেভাবে দিয়েছিলেন।
আইটেম 2 এটা দেয়া হয়নি। ওকে, হ্যাঁ আমি দিব, ক্লাস শেষ করে আমাকে একটু মনে করিয়ে দিও, ঠিক আছে?
ওকে ম্যাম।
তো লিখেছো আইটেম 1 লিখেছো সবাই?
জি ম্যাম, আমি লিখেছি।
Okay. Now the most important topic is classification of solution according to the tonicity. So can anybody tell me what is tonicity?
Turgidity in the cell.
Sorry, I can't get you. Again,
Ma'am, turgidity due to water.
more specifically, what is tonicity?
Ma'am, tonicity can be defined as the effective osmolality.
Effective osmolarity. Then what is osmolarity? What is osmolarity?
Ma'am, it is a number of osmol solute per kg of solvent.
See, here there is a solution in a beaker. There is water and some solutes. Okay. In solute, that is in the dissolved part, and solvent which is dissolving. So this is a cell in our body, okay, and there is a semi-permeable membrane here. We are going to zoom it. The semi-permeable membrane is shown like this structure, okay, in the microscope. So in two sides, we will take, this is the plasma membrane that is semi-permeable. Okay, you know that. So there are water in the two sides of the cell, outside the cell and inside the cell. Okay, this is water molecules are there. And there are also some solute because our body is composed of so many solutes, that is protein or glucose, amino acids, vitamins, minerals, everything. So that are the solute that represent this S, okay, and water. And 70% is water, okay. So which one is hypotonic solution and which will be the hypertonic solution? In this beaker there are water, and in the water there is a cell. See? Hypotonic solution means solution with a low concentration of solutes. And hypertonic solution means solution with greater concentration of solutes. Hypertonic solution, the solute concentration of the solute will be less, and hypertonic solution, concentration of the solute will be greater. Remember this, okay? Then here in the beaker there is solute 20%, 80% water, and in the cell inside the beaker. Listen, there is a time limit of 40 minutes in Zoom. So after 40, it will be disconnected. You need to enter again with the same link and password. Okay.
Okay, ma'am.
Yes, ma'am.
Okay. And in the cell, see, there is 60% water, 40% solute. So which one is hypotonic and which one is hypertonic? Solution in the beaker or solution in the cell? So see the hypotonic definition. Solution with low concentration of solute. So in the beaker, the solute is 20%, and in the cell, the solute is 40%. So the beaker is hypotonic.
Yes, ma'am.
Is that
Yes, ma'am.
clear? So in
Yes, ma'am.
hypotonic solution, the solute concentration of the solute is less. So less. Then which one is hypertonic?
Cell.
Ma'am, in cell.
The solution in the cell, right? 40% solute here. So that is a so what will happen if we place a cell to a hypotonic solution? The cell is hypertonic, but in the beaker that is osmosis. What is osmosis? Osmosis means movement of water from a high to low concentration. Okay. So when we will place a cell that is hypertonic in a
low to high na?
low to high, that is osmolarity, but this is the water concentration. Water goes from high to low. This is water concentration 80%. Okay, and cell is 60%. But here osmolarity is high, so the water will move from low to high. Low concentration of the beaker, not water. Here osmosis definition according to the water concentration, not the osmolarity. Okay.
Okay, ma'am.
Osmolarity is opposite. So the movement of water from high to low concentration of water. So here hypotonic solution and hypertonic solution. So the water will go from low to high, right? From cell to outside or outside to cell? In the beaker to cell or cell to beaker?
Beaker to cell.
Beaker to cell. Yes, so the cell will be swelled. Okay? Until the equilibrium obtained, the movement of the water will continue. In case of when we will place a hypertonic cell to a hypotonic solution, and if we does the opposite, like here there is 50% water and 50% solute, so both are same, but we can say it's a hypertonic solution. See, which one is hypertonic solution? Here in the beaker, there is 50% solute, and in the cell, the solute is 40%. So, in the beaker, the solution is hypertonic, right?
Yes, ma'am.
So, if we placed a cell inside a hypertonic solution, what will happen? The movement of water from high to low concentration. So, here water is 60% and here water is 50%. So, water will come from the cell, right? So, let's
Yes,
see
ma'am.
here. In the this is the hypertonic and hypotonic solution. Clear, all of you?
Yes, ma'am.
Okay. Then now here's 15 water molecule and 5 solute molecule, and another side 5 water molecule, 5 solute molecule, right? So the water will come from left to right until the equilibrium obtained. This is the hypotonic and this is the hypertonic solution. See, they are coming. When the equilibrium will obtain, this both side is the same. Here the 60% water, 33% solute, and 67% water and 33% solute. Both sides, the water and solutes are same. There, this is called the equilibrium state, and in this state there will be no movement of water from the semi-permeable membrane, and this is called isotonic solution. And in our body, all the fluids remain in isotonic state, because if there is no isotonic state, like if in our brain, if the brain is hypertonic and outside the brain it is hypotonic, then the water will come from the brain cell and the cell will be shrink, then will die. So always there will be isotonic in all cells, and outside the cell the equilibrium will be maintained, and if there is any deviation from the equilibrium, there will be volume disorder that you will learn in your fifth curve. Okay, but you need have a clear conception about which solution is isotonic, which solution is hypertonic, and which solution is hypotonic. Is that clear now?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, the examples of this solution you need to see in the books. Okay, you need to memorize that. Okay, then roll number 26.
Yes, ma'am.
First question, what will be the answer in the gap? In a hypotonic solution, there
In a hypotonic solution, there is a lesser concentration of water.
what
But
was the hypotonic solution? Hypotonic solution means
hypotonic solution that have lesser osmolarity than plasma.
means less solute.
Less solute.
More water, then there is a greater concentration of water but a
But
lower
a less
solute.
concentration of solute.
Okay. Now, second question, roll number 48. Roll
Yes,
number
ma'am.
48. Roll, number 2.
Yes, ma'am.
In a hypertonic
Ma'am,
solution,
in hypertonic solution, there is higher concentration of there is lower concentration of water, but higher concentration of solutes.
right. So, number third question, cell will swell or shrink when placed in a hypotonic solution. Roll number 41.
Ma'am, the cell will swell when placed in a hypotonic solution.
Okay. And number 4, that will be the opposite. When we place in a hypertonic solution, it will shrink. Then next question, roll number 36. Roll number 36.
Yes, ma'am.
So a cell has a 65% water concentration and compared to the 75% water concentration of the environment. So is the environment hypotonic or hypertonic?
Ma'am, hypertonic.
cell 65% water and environment 75% water. So the environment is hypertonic.
Yes, ma'am.
Is the cell hypotonic or hypertonic?
Ma'am, hypertonic.
Hypotonic. Ma'am, hypotonic. Cell hypertonic.
So you didn't understand at all. Solution with a low concentration of solute, that is hypotonic. So okay, low concentration of solute. So where there is 65% water, what is the solute concentration?
35%.
35%. And in the environment?
25%.
25%.
25%. So the environment is hypotonic, right?
Hypotonic. Yes, ma'am.
So the cell is hypertonic and the higher concentration is, where is the higher concentration of solute? In the cell. So let's finish here the questions first. So today is the last class of mine with all of you. Actually, I am going to resign. I got chance in a post-graduation course, so my class has already started.
ম্যাম পোস্ট গ্রাজুয়েশন কোথায় করছেন?
আমি এবার আমার হলো শেরেবাংলা মেডিকেল কলেজে।
Congratulations, ma'am.
Congratulations, ma'am. We will miss you, ma'am.
Congratulations, ma'am.
Where I have kept the question. Where are the questions? You can take a screenshot now.
Yes, ma'am.
Okay, after opening the college on 13th, it may take time 1 week to join new teacher. So within this time, if you want to give item 1 and 2 in online, you can give it. I will check it. Okay.
Sure, ma'am.
Okay, ma'am.
Okay, then let me know when do you want to give the item. Today's, you could take today's one, item 1 in one day and item 2 is another day. And if you want to give it to the new teacher, that is also fine. You can keep it online. That will be more better actually. Okay, finished?
Yes, ma'am.
Okay, ma'am. Assalamu alaikum, ma'am.
Yeah, Allah Hafiz.
Allah Hafiz, ma'am.
Ma'am.
Assalamu
Allah
alaikum,
Hafiz.
ma'am.
Allah Hafiz, ma'am.